Well, good evening or morning or afternoon, whatever it is, wherever you are. Um, Evening for me, so I'm based about an hour out of London, so I'm in Ipswich. I think we've got a couple of hours in. I don't think we will need that long, but I can be around for the full 2 hours if people have got lots of questions or want to chat more generally about things anyway. Happy to talk AWS. Happy to talk about anything that you see in this presentation. Um, yeah, so without further ado, we'll kind of go through these slides. They'll probably take somewhere between 10 and 15 minutes. For those of you who were at Codebar in London last month and came to this talk, they are the same set of slides at the start. Obviously, there is the hands-on part at the end. So some new content as well this evening. So you're not going to be just seeing the same thing twice. But for those of you who weren't there, we'll just have a little bit of a primer to AWS, kind of a bit of understanding of kind of what it is and how it's used, the core parts of it, and then we'll get on to some kind of hands-on demo. With regards to the demo tonight, because AWS does cost real money and it's really, really hard to coordinate these things virtually when there aren't people in the room. What I would recommend for this is if you've got an AWS account already and you want to kind of follow along, then please do feel free. But here is the kind of warning up front that things we do will cost real money. It's not going to be a lot of money. We're probably talking pennies. But as with everything in AWS, it can cost money. So what I'd recommend for this first session is that we use it as a bit of a learning exercise. We use it as a way to kind of find out what AWS can do. You will get to see hands-on code. You'll probably see me getting frustrated and breaking things and hopefully fixing them afterwards. But the real kind of goal of this session, because as I understand it, is the first AWS workshop that's kind of been run for Codebar, I think. What I want to do is, if it's something that's well received and people enjoy it, then kind of open up that opportunity to start looking at ways that we can run these sessions and give people AWS accounts where they haven't got to kind of put a credit card in and worry about spending their own money, being able to learn in a safe and kind of sandboxed environment. But that all relies on people giving good feedback tonight. If you are obviously interested. If you aren't interested in AWS, then please don't give good feedback, I guess. So let's crack on. So I will very, very quickly talk about me because it's the least interesting part of this whole session. So as I said, I live in Suffolk, and my current role is a principal solutions architect at Ubertask Consulting. So Ubertask, we kind of work with customers to help migrate their applications to AWS and make them better once they're on AWS. Ubertask have been very kind and sponsored this session this evening. So obviously all of you know that the vast majority of Codebar is voluntary, and all the sessions that run in the various chapters on Codebar, all of these things don't happen without volunteers and sponsors. So I am very, very grateful for them to be able to support what is a very, very worthy cause. Myself, I've been using AWS for probably 5, 6, 7 years, depending on how technical you want to get. As I said, I was at Codebar this year. Hopefully there's some people who I met there. I am terrible with names, so if your name has popped up and I haven't recognized you, I am sorry. But please do say hello in the chat. So AWS. AWS stands for Amazon Web Services. So same Amazon as the e-commerce site that I was going to say online bookshop, but is obviously everything and anything you can buy now. But in terms of AWS itself, what is AWS? So AWS is a public cloud provider. So if you look up the definition of what public cloud really means, all it means is that it's where an organization like Amazon have made computing services available to the general public over the public internet. So the idea being any person can go on, sign up for an AWS account and start accessing these services. Of course, you have to pay for what you do use, but it is public, it is open, it is something that's offered to everybody. You have also got the inverse of this. So private clouds do exist where organizations might build a private cloud inside their company and offer services just to their employees to build things. But things like AWS are public cloud. If you've heard of things like Google's cloud platform, so GCP, another example of public cloud, Microsoft Azure as well, public cloud. All of these kind of compete in the same space. I've kind of bet my career on AWS, so I'm a little bit biased as to thinking that's the best one. But there are lots of options out there, and they all do similar things. So a quick kind of question for everyone. Can I see the chat from here? I can see the chat. So just by kind of yes or no answers in the chat, and those of you who saw this talk last month, don't cheat, please. Is cloud computing a new thing in the industry? Is it something that's kind of surfaced in the last few years, or has it been around for decades? And the majority are saying no. Okay, cool. Correct. So AWS itself, if you go back to the real kind of origins of what AWS was, kind of surfaced somewhere around 20 years ago. Depending on kind of how deep you want to get into it, it's the public references to AWS go back that far. If you had inside contacts at Amazon, I'm sure that people would have been discussing it significantly more than 20 years ago. But in terms of it starting to be available to people like you and I, 20 years ago is about the right point. It's kind of scary because I'm only 26, and it's weird to think of this thing that feels very new and feels very cutting edge actually being around for the vast majority of my life. So just a couple of slides on where AWS originated from. And it's really important to understand the beginnings of AWS as to why they do things the way they do today. So in the very early 2000s, so the sort of 20 plus years ago, Amazon started looking at this concept of what they called a service-oriented architecture. So the idea of this service-oriented architecture was individual teams would be able to kind of build their own services that other teams within the business would use. So the idea is that the whole business doesn't necessarily pull as kind of one big machine. Individual teams get responsibility and also ownership over individual things, and then other teams within the business, if they need to use that service, they can, rather than rebuilding it themselves. So the kind of the key driver for this was that Amazon got frustrated with how long it was taking them to build and release software. So back in these early 2000s, obviously Amazon was, well, even then probably was an enormous e-commerce business, but everything was software. So what they wanted to do is they wanted to take away some of those stresses of building and managing physical hardware. So if you kind of go back further than 20 years, and even now in some businesses, people will buy physical servers, they will have to install servers, configure them, all of these things that take time away from actually writing code that makes a business money is what it comes down to. So for Amazon, is how do we increase that percentage of time where engineers are writing software that makes us money, rather than spending time on doing things that every other team in the business has to do. So 21 years ago, AWS kind of launched their first services, and these were services that were kind of centered around e-commerce. So they were almost like shops in a box, is probably how I describe them. So people could go on, they could create their own online shop, use all of Amazon's software they built internally for themselves. This idea of giving people responsibility to write code that directly delivers value for them, rather than write code for that duplicates what other people have done. And then in 2004, the first kind of infrastructure service launched. So the first thing that was akin to what we see today. So since 2004, obviously the use of cloud and the investment in cloud has just skyrocketed. So AWS now offer well over 200, probably close to 300 different services. We're going to go through a few of them today. Naturally, we're not going to go through 300 of them, because I don't know all 300. I don't think anybody does. But yeah, we'll go through some interesting ones today for sure. So let's skip this one. So there's kind of three pillars of AWS that I want to very quickly touch on before we start looking at some code, and before we start writing some things that we can actually deploy into AWS. So this first one, the best analogy I could come up with was Yo Sushi. So if you haven't ever been to Yo Sushi, Yo Sushi have a kind of a different model of serving your food in your restaurant. So you go and sit at this conveyor belt. The conveyor belt brings your sushi around. Depending on the value of the sushi, depending on the size of the portion, you have a different colored plate. So what then happens is, at the end of your meal, you've kept all of these plates that you have eaten your meal from. Your kind of waiter or waitress comes around, they count up the number of colors plates you've got, and they work out what your total cost comes to. So AWS works a little bit like this, really. So you take the stuff you want, you use it, and then at the end of the month, AWS come around, they count up how many hours or minutes or seconds that you used particular things, and they charge you for it. So if you open an AWS account and you don't use it, you don't pay anything. If you are running a huge business on AWS, then you might be paying millions of dollars a month. the more you use, the more you spend. Similarly to Sushi, the more plates you pull off the conveyor belt, the more your bill will be at the end of your meal. Second pillar is all about building blocks. So the whole idea behind AWS is you can piece these lots of different services together to build one overall solution. So Lego is the best thing I can think of to kind of compare it to something physical in the real world. Lots of different shapes, lots of different sizes of pieces that you can buy with Lego. You piece them together to make whatever model it is that you want. Sometimes you follow an instruction manual to build a particular thing. Same with AWS. Sometimes you follow some tutorials and piece these different services together and build an application. But ultimately, AWS have these almost 300 different services that all do different things, and it's up to you to decide how do I and what do I want to piece together to make my application work. And then the final one, security. So AWS have an interesting kind of security model. So they call it the shared responsibility model, and it's something that's really, really important to know about. And it also means that it's something that if you were to ever want to kind of get a job working with AWS, the shared responsibility model is a really good thing to be able to talk about in an interview. So if you think about your computer at home, so the security of that computer, the physical security of it, you are responsible for that. So you have to make sure that you've got locks on your doors. You have to make sure that someone isn't going to kind of break in, steal the computer. If you are a big business, then same thing applies, or just at a bigger scale. So if you have your own data center, you need to make sure that you've got security guards. You need to make sure that somebody can't walk in and steal a server out of your building. This is where AWS is different, because all the data centers are theirs. So AWS are responsible for security of the cloud. So think of it as anything that you kind of can't physically go and reach, AWS are looking after that for you. So they're looking after the physical security, they're looking after the cables, all of these things that every single person that uses AWS needs, and probably needs to use for 99% of people in exactly the same way. AWS look after that for you. What developers are responsible for is things like the security in the cloud. So it's things like passwords, making sure that users can't do more than you want them to be able to do. Your normal kind of application type things. So similarly to if you sign up for any kind of business software and you say, this person's going to be the admin, this person can then do these particular things. I want this person to be able to view my, I don't know, invoices, for example, but these people shouldn't be able to delete invoices. AWS, you kind of work in the same way. So you can configure, I want this person to be able to view all of my servers. I want this person to be able to only do stuff related to billing, for example. That's where your responsibility comes in, when you're doing the security in the cloud rather than securing the physical parts of the cloud. So enough of the talking, enough of the slides, and let's do some live bits. Okay. Let me just stop sharing my screen for 1 second, and I can then start sharing the right thing. just while I sort that out, did anybody have any kind of burning questions or anything they wanted me to kind of quickly clarify before we move on to start building some things?
What's the difference that AWS has other than the other clouds, and what they are better in?
Yeah, really good question. So for me, so AWS are the kind of market leader. They are the biggest company when you compare to the other clouds, and that does bring them some benefits. So what I've generally found is AWS are the most reliable. They give you a lot of control, which isn't always a good thing, because the more control you have, obviously, the more chance there are to break things. But also, it's I think AWS do quite a good job of having services that cater to both people who want to just get started, but also people who really need to get into the absolute kind of depths of configuring very, very specific things because their application needs it. They seem to be quite transparent about things. So, for example, within AWS, obviously as a global cloud platform, there's this kind of concept of different regions. So if all of your users are in Japan, for example, then you might host your application in Tokyo so that there's less latency between your application and its users. Within regions, you have this concept of availability zones, and each availability zone is a separate data center that is either 30 or 40 miles away from another data center within that same region. So, for example, London region here, there are 3 data centers that make up the London region. So the idea is that if you deployed your application into all 3 of those data centers, if one of them fails, it's still going to be functional to an extent. There's been some cases where other cloud providers have, on paper, had similar concepts where they've said, we've got these kind of availability zones, and if you deploy your application to all of them, then you almost guaranteed that downtime is very, very limited. In practice, some of them have not necessarily been as resilient to those failures as they perhaps alluded to. So I think kind of Google, for example, had an issue earlier this year where I think it was their Paris region where they had a fire in one of their data centers, and it took an awful lot more offline than customers perhaps expected to. And when people are kind of betting their entire business, I suppose, on the reliability of AWS or Google Cloud or Microsoft Azure, you need to have a kind of high degree of trust with them. It's a very long answer to your question, I'm afraid. But at a high level, I think because AWS is the widest used, there's a lot bigger community around it. So you'll find a lot more tutorials, naturally both good and bad. You'll find probably a lot more investment in things like AWS from Amazon than maybe Google do in Google Cloud. Certainly with the kind of customers that I tend to speak to, most of them see AWS as the default kind of, the default one we would go for. Isn't always a reason to go for it, but of those three major players, I think AWS are best placed.
Yes,
Okay,
thank you.
cool, no problem. The service that I want to base a lot of this around today is a reasonably new service in AWS, and maybe a little bit dangerously, it's one that I haven't used a great deal. So I'm kind of learning as much as you are with this, and we'll build something fun together by the end. So this service itself is called Application Composer. So the idea of it is that it enables us to build these architectures in AWS, to build them with a kind of drag and drop builder, take a lot of that kind of mental complexity away from understanding how different things can piece together, and actually enabling us to think about things at a much higher level. So as the kind of description of the talk said today, what I want to try and build is I want to try and build a API with AWS. So we're gonna start off by building the kind of the bits that sit behind the API, and then we're going to move on to building the bit that actually exposes the API routes themselves, and then we're going to add a database in as well. And I think we can achieve it all with this one service here, but we will see. All being well, by the end, we'll have something fun to play with. What I'm going to do is I am going to make the code for this available on GitHub as well. And obviously the recording is also available on YouTube. I think it'll go on the codebar channel. So let's get going with this, and I can kind of talk you through what we do as we go. Yeah, so this is the AWS console. So when you open an account with AWS, you get access to kind of pretty much everything straight away. So this is where you have to be kind of quite careful, because some services are very expensive. So you can, yeah, you need to kind of practice caution, and a real key skill as part of learning AWS is learning how to control costs. As I said, everything that we go through today is going to be really cheap. So if you did want to open up an AWS account for yourself and you wanted to run through this afterwards, then it will be probably fractions of pennies. It's not going to be any significant cost at all. However, like I said, what we will do is, if people are interested in AWS, which hopefully, given that we've got a decent turnout this evening, people are, we can start to look at how we can run these sessions where it's really easy for people to get hands-on without having to put their own credit card on the line. So Application Composer is, as I kind of said, it's this visual way of building applications on AWS. It's a way to with a drag and drop interface, piece these different building blocks together, and it will then do the hard part of integrating for you. We will still have to write a little bit of code. This evening, I'm gonna write it in Python. I think a lot of the kind of the back end tutorials on the codebar website are Python, so we'll stick with that theme, and it's the language I'm most familiar with. yeah, there'll be reasonably limited code writing and lots of AWS stuff. So let's start off by creating a new project here. So down the left-hand side, we've got these different what they call enhanced components. So they're the ones that we're going to stick with today. Some of them we won't use. There's 3 or 4 we will use. Everything else under here, we're not gonna look at. There's obviously well over 1,000 of them. These are the ones that make it really easy with Application Composer to build an application. These require a bit of a deeper knowledge of AWS, and it's possible that you can extend what we build today with some of the stuff you see down here. But maybe that's a good thing for a follow-up session. So of these enhanced components here, we've got 1, 2, 3 that we're gonna use. So the first one we start with is going to be this one here, which is the Lambda function. We're also going to use the DynamoDB table as our database. And then API Gateway is going to be what sits in front of everything and gives us things like our API routes where we can then post data, get data from it, all of these things. So as a wider piece of context, what we're going to build is a kind of simple to-do items app. So the API that we build will allow people to add to-do items. It will allow them to list their to-do items and update them and delete them. And we'll see how many of those methods we get through, but the pattern is repeatable. So even if we don't get through all 4 of those, it's the same kind of concepts each time. So what are Lambda functions? So Lambda functions are a way to run typically kind of small units of code in what's called a serverless manner. So serverless doesn't necessarily mean there are no servers. There are still servers somewhere behind the scenes. It just means that the concepts that are typically associated with a server, you aren't really exposed to. So you haven't got to think about things like, oh, I need to think about choosing this particular type of server so it can have this CPU or this graphics card or something like that. You focus on writing the code and you say, I want to have this much memory. So memory as in the same memory you have in your laptop or your phone or anything, RAM memory. So Lambda functions abstract a lot of that away from us and allow us to just write a real small piece of code to do one particular thing and run it very, very cheap and very, very quickly. So when I've kind of talked about this idea of this obviously costing money to build, but not really costing a lot of money, if we look at the pricing for something like a Lambda function, and we look at what it costs in London, for example. So this is how granular pricing gets on AWS. So if you have a 1 GB function, so you've said I need 1 GB of memory to run my function, and it runs for a second, it's going to cost 0.00001 and then $66667. So that's a tiny fraction of a single cent each time it runs. Now, obviously, for this demo here, we might run requests 10 times. we're not even going to be scraping 1 cent for this. So it can be very cheap. The obviously flip side to that is if someone malicious were to discover your API and you didn't have authentication, for example, in front of it, which we're not going to have for today's, then if someone were to just keep absolutely hammering your API with requests, then that can add up very, very quickly. But we're going to be careful. We're not going to stop me from going on holiday. Hopefully not. Anyway, if it all goes wrong, then someone's going to have to put me up for a week. Cool. So we'll start off with this Lambda function. We can configure everything through application composer. So let's start off at the core of our APIs. Let's start off with a Lambda function that is going to what should we do first? Let's do get items function. Is this zoomed in enough for people? I know my resolution is fairly high. Also lost the chat. Cool. I've got some thumbs up. So Lambda functions can be deployed as 2 different types. One is kind of a package of code packaged up as a zip file. One is as a Docker image. So some of you may have used Docker before, some of you may have not. But for today, we're going to focus on the default one, which is just packaging up some files as a zip file and uploading it that way. And then what this is doing behind the scenes for us is this is actually building a template that we can deploy. So as I go through and change these things here, so I can say, I'm going to put my Python code at this path in my repository. I want to make this a Python application, and everything else, we'll keep things nice and cheap. So we'll say this is going to be a really, really small function. So it doesn't need to do a lot of things. So we'll just go for the minimum amount of memory. Always a great place to start because no need to spend any more money than you need to. You can set things like timeout as well. So obviously we saw there that the way you pay for a Lambda function is based on the number of seconds that it runs for. So if this is something that we expect to take 5 seconds, then actually maybe let's set a timeout to 6 or 7 seconds, so that if it's just running a little bit slowly, then it's okay. But if something goes wrong, we're not going to end up with the Lambda function running for 15 minutes and obviously costing us extra money for no real reason. So for what we're doing today, I'm going to set to 5 seconds because it's really, really quick and we don't need to do an awful lot. Everything else I'm going to leave as it is, as default. I'm going to save it. So we've now got this one function on here. So if we look at what's generated, this has actually generated for us a template. So there's this concept in AWS and in other cloud providers as well called infrastructure as code. So a really good practice to get into is when you're going to start building things in AWS is to, wherever possible, build them as code. So I can give this template to one of you. You can go and deploy it in your AWS account, and you would get exactly the same thing that I deploy in mine because it's all defined as code. It's a really, really nice practice to get into. It's something that in kind of project teams working with AWS is great, because you can do things like you can check this template into your Git repository. So whenever someone makes a change to it, it's tracked. You can see this person is making this change. They've opened a pull request. You can have those conversations rather than just somebody coming into this console in the web browser, clicking around on a few things, and then before you know it, production's on fire, and you've got to get up at 2 a.m. and fix it. So what this is doing for us here is it's transforming this sort of high-level generic Lambda function for us into the AWS infrastructure as code, which is called CloudFormation. So as you kind of might guess by the name, CloudFormation is there to help you form things in the cloud. One really nice thing we have with Application Composer is it can actually sync these changes down to a folder on your local machine. So that's what I'm going to do today, because we can't write our Python code in here, but we can build out our infrastructure to support our API. So we can do this here, and we can say activate local sync. We can select a folder, and let's go into dev and codebar. Let's create a new one called Intro to AWS Talk. And we're going to choose that. Let's just give Chrome the permissions it needs. This does seemingly only work in Chrome and maybe Safari. I tried it in Firefox last night when I did a dry run of this demo, and it didn't work. It might be Marika, depending on what your browser is. So I know that Chrome is supported, but things like Firefox aren't. Other browsers like kind of Brave and Arc, I suspect, are probably not. It's also potentially, if you've got ad blockers and stuff installed, or any privacy extensions that might be blocking access to local file systems, that can also have an issue. So we've got this here. If I hop over here and just look in this folder, we can see our folder we've created. We can see these files that have been created through that synchronization. So I'm going to open it up in Visual Studio Code. I do trust myself most of the time. And let's again just zoom in on this so that we've got it big enough for people to see here. Okay. So we can see in here, this template is the same as it was in our browser. So we've got this syncing up nicely now. It's also actually created for us the Python file that we need inside the right location for our function here, which is really nice to have as well. So it kind of gives you that head start straight away. So the first thing I'm going to do is I'm going to deploy what we've got to AWS. So at the moment, if we look at the Python code, all it's doing is it's going to take the contents of whatever we give to this Lambda, and it's going to print it out. And it's going to print it out in a like a log file. So for now, that's okay. let's stick with that, just so we can prove that it works, it deploys. This isn't all a big act of magic. So there's a command line tool that AWS have called AWS SAM. SAM stands for serverless application model, and it's a really easy way to deploy the things that the application composer is creating for you. So what I can do is I can hit SAM deploy. I've already set up my AWS credentials, hopefully. We can just check quickly. I have, lovely. So we can hit SAM deploy. I'm going to tell it that I want to deploy it into the EU West 2 region, which is London. And I told you I'd break something. The first time you run this, if you also supply the guided option as well, what it will do is it will prompt you for a few options that are required to deploy it. So it needs to have a stack name. So when you deploy a CloudFormation template, it goes from being a template to a stack. Think of it in the same way that when you write when you're writing software, you might have a class. So in JavaScript, you have classes. Python, most languages have the concept of a class. When you instantiate that class, when you do new something, you are turning that class into an object that you can then interact with. It kind of becomes real. Deploying a CloudFormation template into a stack is the same kind of idea. So we're going to set our stack name as codebar demo. We've passed our region to it already, so it's defaulted to that. We are going to say yes to this one because we want to see what's being created before we deploy it, just in case something goes wrong. We're going to say yes to this so it can create what it needs to create. And we are going to say no to this because we're going to get it right the first time, fingers crossed. And we will save these to a configuration file. Okay, so this is going to go and create some things in our account for us now. So what we will see is if I hop over to the CloudFormation service in here, you can see from what I've just run, it's creating a stack here, which is as a result of me saying yes to this question here. So what it's doing is it's going to go and create anything it needs to store things like those zip files. So it will store those zip files in a storage service in AWS called S3. Once it's finished creating this, it's then going to go on and deploy our application as it is so far. So we can see at the moment it hasn't done anything because it's as we asked it to. It's just checking and saying, okay, what is it that you're expecting to create? This is what AWS are going to create. Are you happy with it? In this case, we're going to say yes, because it's what we expect to see. And this won't take too long to deploy. Although when you have people watching, it always feels like it takes an awful lot longer. Cool. So that has successfully created our stack. So we will now see in here, it's created some resources for us. So it's created this get items function, which is our Lambda function. It's created a log group to store our logs. And it's also created for us a role. And roles are what the Lambda function will use to have permission to do particular things. So later on, we'll look at things like connecting to a database. So we'll give the Lambda function role permission to write and read from that database. Think of a role as a bit like a hat. The Lambda function is putting this hat on to assume a particular persona. Roles can be assumed, it can be unassumed. They are essentially a set of credentials that allow you to do very particular things. And again, you can configure what those particular things are because you are responsible for security in the cloud. So if we look at this, we can see we've actually got our Lambda function here deployed. It's in our list of things. It's running Python 3.11 like we asked it to. And what we can do, we can see our code and we can just create a simple test for it. And this is going to run, and we will hopefully see printed out in our logs the event that we passed to our Lambda function. So we can see this is what we passed. So key 1, value 1, key 2, value 2, etc. And then we can see here from our logs, this is what ran and got printed out. So we've got something deployed. It's fairly basic. It's not really doing anything for us. It's just running some kind of very simple Python code. But you can see how quickly this ran. So this ran in 19.3 milliseconds. So for a lot of tasks, it really is going to cost very, very little money. And yeah, people make careers out of optimizing this so it's as low as possible, because when you start to scale up, if you can take something from taking half a second to a quarter of a second, then you half the cost of the Lambda function running, which is really nice. So we want to do something a bit more interesting with this. We want to actually start making this into some form of API. So for that, we're going to use API Gateway. So API Gateway, again, it's another serverless service. You haven't got to think about kind of, I need to create a server, I need to install this software on it in order to run this. You just say, I want an API, I want this to go to this Lambda function when someone visits this particular route. So what we can then do is we can then connect things up. So we can say, okay, this first route here, which is going to be a get method. So just as a very kind of quick high level, your different HTTP methods are sort of designed to do different things. So get will either get a single item or a list. Put is generally used for updates. Post is normally used for creating new things. And then delete is fairly self-explanatory. So we're going to start off with a get one, and we're going to set the path to be /items. So our API will be whatever the start of our API is /items, and we will then get back the contents or whatever is returned from this Lambda function. So we are going to just create this and not change anything else. The one thing I'll call out is we aren't adding any authentication to this. So in theory, anyone could go and hit this API. So we'll make sure we destroy the resources afterwards as well, because you don't want to leave things public. Even though there's no sensitive data there, it obviously can cost you money. So just by dragging these things together here, what we'll see is there's a few things that are added automatically for us to our template. So we can see straight away we have this new API resource. We haven't had to go and look at any documentation for this. Application Composer is just creating this for us with good practice. Then with the Lambda function, it's then connecting that up. So it's saying, okay, when this particular API receives a GET request to /items, I want you to run this Lambda function. So if we then look in VS Code, we should also find it's updated here. So this kind of continuous sync is really nice because we can then go and update things in VS Code, redeploy it, and have an API really, really quickly. So what I'm going to do is I'm going to take this from here and I'm going to do something a bit more interesting. So as a kind of intermediate step between this and having a database, I'm just going to return some kind of dummy data. So the first thing we're going to set is a status code. And that's going to be 200, which is the HTTP status code for success. And then in the body of the response, I am going to return, this is going to be for getting a list of items. So let's return an array. It'll be an array of objects. So we're going to have something called ID. And let's just go for like a title. Deliver codebar talk, which is on my to-do list today. So what we'll see now, if we run that same command again, so because we've now run SAM deploy with that guided flag the first time, it saved those configuration options in a file for us. So the second time we run it, it's going to pick them up automatically and be able to automatically deploy without us having to answer those questions again. So what we're saying this time is there's a few things being added and one thing being changed. So we've got some resources being created that relate to our API. We've got this resource being created, which is allowing the API to run our Lambda function when it needs to. And we're changing the Lambda function because we've just changed this code to return some dummy data. So let's deploy this. And then what we will do, we will just wait for that to roll out. Okay, cool. So that's now rolled out there. So we can then see, we'll see in here, it's still as we had it. In our CloudFormation stack, we've now got a whole load of new resources. So we can go and look at our API. Apparently there's a new console. Let's try this together. We can then see in here, there's a lot of information that we haven't had to kind of look at or define ourselves because as part of that application composer, it's made it an awful lot easier for us. What we can do is we can get our URL from here. So I'm going to copy this. And what did we say? We said it was /items, didn't we? Okay. So I'm going to use curl just to get this and see if this, okay. So we can now do a live demo on how to debug things. So it's made a request, but we've got an error. Always happens with live demos. So let's go and have a look at some logs. So Lambda functions will always log to a service called CloudWatch, and more specifically, CloudWatch logs. So we can go in here and we can see this was the request we just made at 19:06:57 my time. And we can see that there weren't any errors, interestingly. My favorite type of debugging. Let's get through here. Okay, so it's the error we're getting back didn't actually get logged, which isn't overly helpful. It's complaining that the response that we're sending back isn't compatible with the API service. So what we're going to do is we are going to do what every good developer does, and we are going to find the answer on Stack Overflow. So I think the problem is, I think body needs to be a string rather than what I've set, which is a list. So let's set this to do something more like this and try that again. Let's redeploy. Nice and quick. Nice. Then let's try. There we go. It was that. So this has now obviously returned what we would expect to see, which is our kind of dummy response from the API. But really, the database should be where this data is stored. It should be something that's dynamic. We should be able to extend this quickly by getting data from the database, and then we should be able to do endpoints as well that we can add data into our database. So let's focus on adding data first, I think. So if we go back over to Application Composer, I want to create another Lambda function. And this time I'm going to put post item function, call that the same thing. Again, set that to the minimum, keep our costs under control, and set that to 5 seconds. Then we're going to add another path to this. So we're going to say this time it's post to items. And we are going to save that and connect those two up. Lovely. So if we now look at VS Code, we should then see we have now got another Lambda function with similar things again. We should see we've got another folder in here, again, with that same code. So what we want to do is we actually want to import now the AWS SDK for interacting with other services. Probably what is more important is if we create the database first would be really useful. So let's drag on this DynamoDB table. So DynamoDB table is a little bit different to a lot of tables you will have, or a lot of databases you will have come across before. So DynamoDB is known as a NoSQL database. So you don't have the concept of like lots of separate tables and joining them together and all of the things you would normally do with something like MySQL. DynamoDB, think of it as a kind of key value database and a collection of JSON objects. So it's very, very fast, very, very scalable. It underpins an awful lot of Amazon.com. So yeah, very, very, very scalable. So we're going to create this table just with the default options again. Will be fine for what we want to use it for. And we're going to connect up our post item function to our items table. And the reason we want to, or we'll both of them actually, the reason we want to connect them is so that these functions have permission to do things like read, write, delete, etc. from that table. So again, if we now look back in our template that's being created, we'll have another resource at the bottom, which is items table. And we'll see that's added to our Lambda functions. We've got these policies where it's a CRUD policy, which is create, read, update, and delete, and it's referencing the table we've created. So what we want to do is we want to take the input to the API and we want to store some of it in our database. So what can we do? First of all, let's look at what the input will look like, I suppose. So perfect time for documentation. API gateway. The AWS documentation is normally pretty good. Here we go. So we can see what comes into our Lambda function when it comes through the API. So the most important one that we're interested in is going to be this one here, which is our body. So we are going to just pass a string to our API. So we're going to post just a message that we want to be our to-do item title. So let's first of all, let's get that out of the event. So this event here is going to look something like this big blob of JSON. Again, the bit that we're interested in is that. So then what we want to do is we want to be able to write something from this Lambda function to our DynamoDB table. So we can see automatically, as part of that application composer template generation, it's actually very helpfully set up some environment variables for us. So environment variables get passed into the Lambda function, and you access them the same way that you would outside of AWS world. So we can create a Python variable here, and we can get it from the environment variables. And naturally, we need to import that. We can also then create things like, what is it? It's going to be using the SDK. We can get a resource for our table. Trying to remember how it goes now. I think it's like this, and then like this. We'll soon find out anyway. What we also want to do is, because DynamoDB is a key value database, it needs a unique key for every item. And you might end up creating 2 items with the same title if you really wanted to. So we don't want to rely on that title as our unique key. So I'm going to import another package here that comes built into Python, which will allow us to generate a unique ID. So we'll just do that above this here. Let's do uuid.uuid4. So the chances of getting duplicates of version 4 UUIDs is extremely small. So we can be reasonably confident that that's never going to collide. So we've got this now. We've got the title of our to-do item that's going to come through the API. We're going to generate an ID for it every time we create a new one. So what we need to do is we need to use the AWS SDK to put an item on that table, and our item is going to look like this. So we are going to say ID will be item ID. And you'll notice that when we created our table, the only key, the only kind of column that we actually defined was ID. Everything else can be flexible. So as long as you have at minimum a unique column, the rest of it can be kind of whatever you want. There's lots of things you should and shouldn't do for performance that could be a series of talks on their own. But for today, we can just do something like this. So we know that we've got to have this one, but we're going to add another attribute in there called title. Okay. So that's going to put an item there. And then let's just return a helpful response to say something like item created. So we've written our code here. Again, we haven't really had to think about anything in this file. If I hadn't shown you this file, you wouldn't have needed to know it was necessarily there to do what we're doing today. So let me deploy this again. And we will see if this code works first time to put an item into our database. we can see here what it's doing is it's obviously creating our new Lambda function role for our new one. It's created our DynamoDB table. It's updating the role for the Lambda function we had already because we've just given it some new permissions by attaching it to this table. Starting to near the end now of what it needs to do. There we go. Okay. So first thing we will do is we will just run this again, make sure it's all still okay. Yeah, so our sample data is still returning happy days. Then I'm going to change this to a post. And I can't remember how to do a post request. And I haven't got Postman installed. -D, okay. So we are going to just send some data that is finish codebar talk. And let's see what happens, shall we? Okay, so we got an error back. This could be for a number of reasons. Again, let's dig into some logs and find out why. This time, I think it will be in the logs. I suspect it's something to do with me not setting up DynamoDB quite right. Yes. So when I define DynamoDB here, this is creating an object that we can then interact with. What I should have done is do that. So let's very quickly just redeploy that again. I should have had one of those kind of Blue Peter style, here's one I made earlier, type demos. These are more fun. Okay, so that's redeployed. Let's try that again. So we've got a successful response back. Let's see if it really was successful, shall we? So we can now look at DynamoDB. We can see we've got a table here that's been created with our reference in there for items table. And if we look at table items, we can see we've got our new item in here. So we are now posting data to an API. Given that we've been getting on for 90 minutes now, what I think we will do is we will kind of round this out by linking this get items one up as well, so we can retrieve the data from the DynamoDB table and return our list of to-do items, and then probably call the demo there, and we can then open it up for any questions people have or general. If you want to just chat about anything, I'm happy to do that also. So let's round this out now. So we've got our example function here still. It's just we're going to return our sample data. First thing we're going to do is we want to just check and make sure that this environment variable that we passed to the post item function does also exist on the get one, wherever it may be. Yeah, so we can see here for our get items function, it's automatically added those variables into there as well. So we can copy and paste a lot of this code. So let's take everything at the top here, I think, and get that in place. Then what we're going to do differently is we are going to do response, and then it'll be table dot we can do table dot scan, and scan will return everything in the table. Scan is normally discouraged because it has to get everything back from the table. So similarly to a normal sort of relational like MySQL database, if you do select star from users, then it's a very expensive operation in terms of it needs time, it needs power, and it can slow the rest of the database down. Doing a scan on DynamoDB is a very similar thing. Obviously expensive in terms of it will also cost more money because you're retrieving more data from the database. So what's often recommended is that you use query instead. So what you can actually do is you can then say things like, my query is the key should match this particular thing. So if we were building this application for multiple users, for example, we might say, actually, our key on the table is is maybe a unique key for the to-do item. We might also have a second field in there, which is going to allow us to query on users, for example. So we could say, this item belongs to this user. So when I query it, I'm only going to pull the stuff back that relates to my user, which cuts down how much data you have to retrieve. For what we're doing today, and because it's only really me that's going to be using this to-do app, we can just stick to this scan method, but it's not something you tend to see very often in practice. This is where I think it returns something under the items key in this response. So I'm gonna gamble and hope that it pays off and say, let's just return our response items and see what happens. So every time we're deploying this, what's happening is the SAM command line tool is taking things like our code in here. It will take the requirements file as well. So if you have any third-party dependencies, you can list them in here and it will install them as part of the build process. It's packaging it up into zip files. It's uploading it to our storage service S3, and then automatically injecting the location for you as part of this process, so that when the Lambda function runs, it knows where it's where to get that code from. So I got a question in the chat around the costs for DynamoDB. So pricing for DynamoDB works in two ways. One is you pay per request made to DynamoDB. And the other is you can provision capacity. So think of it as you aren't paying for storage as such. You're paying for how much data you read and write. So if you were creating a DynamoDB table and you loaded a load of data into it, and then you never read from it again, you would pay once for that writing of the data, and then you wouldn't pay any more. Just trying to Oh no, I tell a lie. You do pay for storage. I was thinking something else. So you pay a flat rate for storage, so just shy of 30 cents per gigabyte per month. And then this is where it gets a bit more complicated. So this is based on the amount of data you read and write from DynamoDB. So much, much cheaper to read than it is to write. So it's designed for very, very high throughput workloads. But the best thing to do if you are thinking about using DynamoDB or any AWS service, to be fair, is to use the calculator. So if you go to calculator.aws, you can go in here and you can say London, for example. If we just follow what we've done today, we're using the on-demand one where you pay for every request. Standard class, let's say we've got 100 gigabytes of data stored in my DynamoDB table, and our average size of each item is 1 kilobyte, for example. Then in terms of our writes, we could say, okay, we are doing, let's say, every day we're doing 100 writes to DynamoDB, and every day we're doing 500 reads. So every day, that's a reasonable rate, or even if we add a 0 onto both of these, you can see that went up 7p or 7 cents by adding these writes in here. So unless your throughput is really, really huge, unless you're doing an awful lot of writing and an awful lot of reading, most of the cost will be in your storage. In terms of availability, it's going to be 99 point many nines, 3 nines. So 99.39's availability, if you want to work out what that actually equates to. That's 6 minutes of downtime per year. For most people, that is absolutely fine. For some people, maybe not. But the vast majority of customers, 6 minutes a year of downtime is, a tiny scale. Okay. Where were we? So we've deployed this. We've got that update in there. We've got our new code, which we haven't tested yet. So let's run that curl command again to get our data and see what it does. Lovely. So it's actually returned the data from our database to say this is our ID and this is the title. So if I were to send another one in and say, answer questions from interesting codebar audience members, creates our item, we can then get that, and we can then see we've then got our second item in there as well. So the majority of what I've done has been configured through dragging and dropping on here and then writing these two Python files. The beauty of building everything with infrastructure as code and having it all in this template is that I can now do this I can say Sam, what is it? Sam, delete, not destroy. I can say yes, and I can say yes again, and it will go and it will tear down all of the resources that I've just created. It will take away the API, it will take away the database, take away my Lambda functions. So obviously when this recording goes live and people see the API endpoint, which has got no authentication on it for the purposes of speed during this demo, someone malicious can't go and send crazy amounts of data to it, and as a result cost me a lot of money. Yeah, that's a nice benefit of having infrastructure as code and making use of those tools like SAM and CloudFormation, which is the underlying technology within AWS. That, I think, is probably a good place to stop. I don't know how many people we have got left, because I can't see a count of people. We've still got a few. So 23, cool. Thank you for sticking it out to the end. I hope there's been something in here that's useful and interesting. If there is anything that you want to ask, if you want to ask kind of offline, then I'm in the codebar Slack, or feel free to connect on LinkedIn and drop messages and stuff through that. I don't mind anything like that, or email or whatever. I'm more than happy to talk about this stuff. If I don't know if codebar do kind of post session surveys or anything like that, but we can, what would be really handy is to know if AWS is something you want to see more of. If it is something you want to see more of, then I can work with Amazon themselves to get some help from them in delivering some sessions. Codebar, as a global charity, would align quite nicely with obviously AWS people globally being able to deliver some stuff in person. I'm always happy to do things in London or even the UK more generally, but much further afield, and it gets hard to do on a voluntary basis. But yeah, if it was interesting, then please do make comments known if there's things that you think would have been better, or if you thought it was terrible, then equally please do let me know, because I won't do it again. And yeah, I hope you've enjoyed it, and I hope you have a good evening, I suppose, for most of you.